right. Let's see. This is a new worksheet, guys. It will be worksheet 33, sheet 2. Right? I'll go ahead and upload that. All right, so sorry. This is on sets and probability. The last worksheet we did, which was on the introduction to probability, I believe the last question was left up to you. If you do have any questions on that from the last sheet, guys, please don't hesitate to ask me. I believe I did all the way up to question 4. The last question was exercise 4. I did not do. All right. So, if you do have a question on that, please ask me. I'm going to move on to sets and probability. So sets and probability is pretty straightforward. It's essentially just the same thing we were doing with probability, except with sets, meaning that you do need an event and you do need a sample space. But in the case of sets, it's going to be slightly different. So let's look at this. Since the basic calculation within probability involve counting the number of outcomes that fit into a particular event, it makes sense to have a tool to visualize and keep track of all the outcomes in a sample space. We will do this by using sets. Recall the basic definition of a set. A set is simply a collection of things, right? You can have numbers, objects, letters, etc. that satisfy a well-defined criteria. The things that are contained in a set are called the elements of the set. All right. So next exercise 1, it says, the set A is defined as the collection of all integers that are greater than 0 and less than 10. So I'll draw a little circle, which is usually how sets are represented. Okay. We'll set A greater than 0 and less than 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. I can also say this right here, A, in the roster format. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we have our sets. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? This is right set out in roster format. So this is what we did for A. Now B says show set A in Venn diagram form. That will be a very simple Venn diagram. All right, which is simply that. Keep in mind, Venn diagrams will have so if we wanted to show it in A, right, in Venn diagram form, so we can say here, A, we have this like right here. That's essentially a Venn diagram, right? So we want A, again, this is all set A, right? Which is going to be greater than 0 and less than 5. greater than 0, less than 10. So we have 1. If we were to go totally in a line from 0 to 10, right? We could do this. Actually, let me make this a little bit better. So make like this, like that. Okay. So from 0 to 10, right here. Then right in between, right here, would have 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So again, this fills the requirement, right? So in my Venn diagram, right, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So C says a subset is any set whose elements are all contained within another set. Given two possible rules that could define subsets of A, right? Or I think you could have also, just for the subset for A, Venn diagram, you could have just done this by itself. And 1, 2, 3, 4, 5, 6. Right, so it says given two possible rules that could define subsets of A. Sorry, it's not given. It says give two possible rules that could define subsets of A, and then write the sets as B and C in roster form. Do sets B and C have any elements in common? Okay, so two rules that could be subsets of A. We can say greater than. So B, we can say B, subset B is going to be greater than 3, and B will also have to be less than say 8. Right? That's a subset. So it's going to be greater than B, and it's greater than 3 and less than 8. So we could say that subset would be 4, 5, 6, 7. Right? And we can define another set, C, where we can say C is less than 3, but greater than 1. Right, so in that case, we would just have 2 as being in our subset. That's clear? I'm clear on how we make the sets and subsets, right? So you have a set which has all the elements, universal elements. Then you have a subset below that, which are elements from that universal element, right? Let's try exercise 2. It says, consider an experiment where we first toss a coin and note the outcome, and then roll a 6-sided die and note the outcome. Write a set of ordered pairs, such as H4, that represent all outcomes for this experiment. Recall that this is called the sample space. We will generally call this set S. Okay. So if you see an example that you flip the coin, you got a heads, and then you roll the die and you got a 4. So if we wanted to be able to all outcomes, we would just do it like this. Erase all this, man. So, okay, so in the first set, right? This is going to be a sample space, so okay, so these are outcomes, right? Together they're going to equal sample space. You can have heads or tails. Then, after you get a heads or tails, say you get a heads, you can get a 1. One, 2, 3, 4, 5, 6. If you get a tails, you can get a 1, 2, 3, 4, 5, 6. So if we were to list our entire sample space, right? That would be H1, H2, H3, H4, H5, H6. H6. All right. We can do the same thing for tails, right? We can do a different color. T1, T2, T3, T4, T5, T6. Right? So our entire sample space would be all of these elements entirely. Recall that this is okay. Blah 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 blah. Okay. Set of order. Write a set of ordered pairs such as that represent all the outcomes. Okay. All right. So for B says write a set of ordered pairs that represent the event of getting a tail and an even number. We call this set A. All right, so we say set A, right? We say A. We'll do it in roster format, right? It's tail and an even number, right? So we can get T2, we can get T4, or we can get T6. You have any questions on this so far, guys? Don't want to do this entire page. Let me do question C in the nab. That'll be it. Unless anybody has a question. So now C says the complement of set A will be all of the events in the sample space that do not fall into set A, right? Write out the complement of set A. We'll call it set B. Okay, so basically set B, I'm not gonna write out for you guys. This is T6 right here. Set B is going to be T1, T3, T6, H1, H2, H3, H4, H5, H6. It's gonna be all the events. And then D, essentially, so I hope you guys understand that. D is essentially going to be, you want to be able to find a probability of getting A, which is your set A. Your set A is going to be 3 over, how many choices do you have? 12? 3 over 12. Or 1, what is that? 1/4. And for probability of getting B will obviously be 3/4. Essentially 9 over 12. So this is 1 over 12. Sorry. This is going to be 3 over 12, which can be reduced to 1/4, right? And that's probability A. And probability B is going to be equal to 9 over 12, which is going to be 3 over 4, 3/4. All right, guys. there's no more questions on this, guys. You hear some commotion in the backdrop, so I do have to wrap this up. Any questions on this at all? Please, anybody ask me, because this is going to be the second sheet. I'll post this probably within the hour. Any questions? Any questions? All right. If there's no questions, more questions on this, guys, I'm going to end this. I'm going to end this live session, and I will see you again next Tuesday. Make sure to complete this sheet as well as completing the other sheets, the study.com assignments. All right. I'll probably post another study.com assignment too. All right.